Hello, everyone. So I am not feeling well and will not be able to make it to class today. So I'm going to do a video lecture to replace class today, April 10th, Monday. All right. So today we're going to be talking about the law of sines and cosines. This is homework 11, and we'll be working through this this weekend, and homework 11 is due next week, Sunday, which is April 16th at midnight. Okay, so let's get into this. Law of sines and cosines. This is going to help us work with triangles that don't have a right angle in them. So everything that we've been working with thus far has been a right triangle. So right triangles, just to kind of refresh you, have to have a right angle. When you have a right angle, the side opposite that right angle is called the hypotenuse. Um, And we've been working with right triangles all semester long. Pretty much every triangle that we've had so far has been right. Now, when we have a right triangle, the tools that we have at our disposal are the Pythagorean theorem. A squared plus b squared equals c squared. And again, that c has to be a hypotenuse. You need a hypotenuse to have the Pythagorean theorem. The second thing that we've been working with that we have with a right triangle is trig functions, our basic SOHCAHTOA, that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You need a hypotenuse to have SOHCAHTOA. You need a right triangle to have our standard trig functions. And the last thing that we've been using to specifically to solve right triangles has been the fact that all three angles add to 180 degrees, or pi radians if we are in radians. Okay, so that's where we've been all semester long. Homework 11, we start to tackle, what if we don't have a right triangle? What if we have something that looks like this, that doesn't have a right triangle or right angle in it? Or what if we have something that looks like this? That doesn't have a right angle in it either. This one in the middle, this is called an acute triangle. Basically, an acute triangle is a triangle in which all three angles are less than 90 degrees. All three angles are acute. Something like this down here on the bottom, this is called an obtuse triangle. And we will have an obtuse triangle when one of the angles is obtuse. That means that one of those angles is larger than 90 degrees. That's an obtuse triangle. Now, with these guys, obtuse triangles and acute triangles are kind of lumped together underneath the same umbrella that we call oblique triangles. Basically, oblique triangles are triangles that don't have a right angle. So we'll either be acute or obtuse. And what tools will we have at our disposal with oblique triangles? Will we have the Pythagorean theorem? Well, no, we don't have a hypotenuse. The Pythagorean theorem's not going to apply here. How about SOHCAHTOA? No, we need a hypotenuse. We need a right angle for that as well. Standard trig functions will not apply to these oblique triangles. How about all three angles adding to 180 degrees? Yes, that's true for every triangle, not just right ones. So for right now, that is the only tool that we have at our disposal thus far for oblique triangles. Okay, so basically we're going to figure out how to solve oblique triangles. If I have some information about them, how do I fill in the missing information? So we are going to use something called the law of sines and the law of cosines to help us. Now, which one we're going to use depends on the information that we're given. Now, in ALEKS, the topics are pretty much going to tell you whether you need the law of sines or the law of cosines. But on a quiz or a test, am I going to tell you which one to use? You're right. I sure am not going to tell you which one to use. You have to know when to use what. So this table here is going to help us with that. These are the different situations that we can find ourselves in with given information, and we're going to figure out which method to use to solve that triangle. Okay, so if we are in an angle, angle, angle case, that means that the information that we're given is all three angles of a triangle. We're missing all of the sides, but we have all three angles. To solve that one, we actually can't solve that one. There's not enough information here. Not enough information. So if you have all three angles of a triangle, that's not enough information to be able to solve this out, because any triangle with those three angles is going to be similar. It can be scaled up or down and the angles will remain the same. So we need at least one, the measurement of at least one side to be able to lock in the size of that to let us solve it. But if we don't have a single side, we can't solve that triangle. We don't have enough information to do that. The next case is angle, angle, side. This is when you're given two angles and the length of a side that is not between the given angles. We'll get to what exactly that looks like in a second, but if you have two angles and a side that is not between them, this is a law of sines situation. Again, we'll talk about why in a little bit and exactly how to use the law of sines and cosines, but for now, I just want to be able to figure out where to start. All right, angle, side, angle. This is when you are given two angles and the length of a side in between them. So if you are given two angles and the length of the side between them, this is another law of sines situation. And again, we'll talk about why in a bit. The next situation is side, side, angle. This is when you're given two sides and the measure of an angle that is not between the given sides. So if you are given two sides and the angle and an angle that is not between them, this is also a law of sines case, but this is a special one. I'm going to label this the ambiguous case. We're going to solve this with the law of sines, but we can have 0, 1, or 2 solutions here. And again, we'll talk about that hopefully at the end of the video today. I'm hoping to make it to that point, and we'll figure out why the ambiguous case is what it is. But we'll use the law of sines for that as well, but we call that the ambiguous case because we can have 0, 1, or 2 solutions depending on the information that we have. Next situation we can find ourselves in is side, angle, side. This is when you are given two sides and the angle that is between them. So when you're given two sides and the angle between them, this is a law of cosines situation. And then the last situation we can find ourselves in is side, side, side. We are given all three sides of a triangle, but no angles. This one, we actually can solve. We have enough information for this. And this is the law of cosines as well. Now, the reason we can solve a side, side, side when we could not solve an angle, angle, angle is because when you have all three angles, again, we don't know the scale of it because all similar triangles have the same three angles in a triangle, but different sizes. But with side, 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 knowing the length of the three sides locks in both the size and the shape of your triangle. And so we can solve that one. And the law of sines is going to help us do that. Okay, so let's figure out in each one of these situations which situation that we're in, which scenario, and whether we're going to use the law of sines or the law of cosines to solve that triangle. Excuse me. So this triangle that we have, triangle ABC, our angles are labeled with capital letters. So angle A here is this guy, C is this guy up here, and B is this guy here. And then the sides are labeled with lowercase letters, and typically the side, opposite, and angle have the same letter. So side A is opposite angle A. Side B is opposite angle B, and so on. That is our kind of standard naming scheme. Which angle is A, which one's B, which one's C can vary, but typically once you lock in where your angles are, the sides are labeled opposite those angles. Okay, so let's start with number one here. We have the angle A is 15 degrees, angle B is 40 degrees, and side C is 12 inches. So again, in our triangle here, if this is A, B, and C, then we are given that angle A is 15 degrees, angle B is 40 degrees, and side C, which is here opposite angle C, that's 12 inches. Then we are given two angles and the side in between them. So this is angle, side, angle. And if we have angle, side, angle, this is a law of sines situation. So we will use the law of sines to finish solving this triangle. Again, to see that angle, side, angle, right here, two angles and the side between them, that's law of sines. All right, so hopefully you see what we are getting at with that table. Pause the video here for a minute, run through these on your own, and then we'll go through them together when you're ready. All right, so let's go through this. So get a triangle for each of these, and then we'll go through them. The triangles don't have to be perfect. We really just need to figure out what information that we have in each situation. Okay, so number two, side A is 3.7 meters. Side C is 6.4 meters. And angle B is 23 degrees. So we've got two sides and the angle between them, that is side, angle, side. And this is a law of cosines situation. And to see that, you can hop on up here and see that side, angle, side is a law of cosines. All right, number three, side C is 15 centimeters. Angle B is 70 degrees. And angle C is 45 degrees. So we have two angles and a side that's not between them. So this is an angle, angle, side situation. And that again is the law of sines. Angle, angle, side, law of sines. All right, here we have that angle A is 42 degrees, angle B is 18 degrees, and angle C is 120 degrees. We have angle, angle, angle. This one we can't solve. Angle, angle, angle is not enough information situation. All right, last one here. Oh, not last one, sorry. Last row. Let's do that. Number 5, angle C, which is up here, is 26.8 degrees. Side C, which is down here, is 36.8 feet. The 3. And side B, which is over here, is 13.5 feet. So this one, we are given two sides and an angle that's not between them. And so this is side, side angle. This is a law of sines scenario. And again, this is our ambiguous case. And so again, we'll talk about what that means, but side side angle, that's law of sines. And this is the weird one. And we'll get to why in hopefully in a few minutes. All right, last one, number 6 here. Side A is 15 yards, side B is 12 yards, and side C is 18 yards. This is side, side, side. We're given all three sides, and this is a law of cosines situation. So we would use the law of cosines to solve that one. All right. So these are all of the situations that we will find ourselves in with given information. You won't see this situation where we give you all three angles and you can't solve that. You won't see that one in ALEKS. But I just want you to have the information and know that you can't solve something that looks like that. But the other 5 scenarios you will see in ALEKS. And again, ALEKS will tell you which one to use. I will not. So now that we know which one to use when, what do these laws actually say and how do they help us? So let's start with the law of sines. I'm going to make our similar triangle up here. This, how did we label this one? So A and B and C here. And then this is side A, this is side B, and this is side C. All right. So law of sines, the way that this one works is that we're going to use the sine function and we're going to figure out how to use it to our advantage in this triangle, even though we don't have a right angle. And the way that we are going to do that is that we're going to create some right triangles in here. I'm going to pick angle C and I'm going to draw an altitude down from angle C that creates a right angle on both sides here. Now, when I do that, this altitude, I'm going to call the length of that h. And when I drop this altitude down, this creates two triangles for me. This triangle here on the left, that's a right triangle here, and it creates a right triangle here for me on the right. Because each of these triangles is a right triangle, I have all of our usual tools inside each one of those smaller triangles. So I've got the Pythagorean theorem, I've got SOHCAHTOA, I have all three angles add to 180 degrees. So let's start with this triangle on the left here. If I look at angle A, do you agree that the sine of angle A in this small triangle on the left is opposite, which is this height of h that we just added, over the hypotenuse of the triangle, which is this guy opposite our right angle? The length of that is b. So the sine of angle A is h over b in this left triangle. Similarly, if I look over here at this right triangle over here, then do you agree if I look at angle B here that the sine of angle B is opposite, which is again this height here, which we called H, over the hypotenuse. The hypotenuse of this right triangle here is this one here, which is A. So the sine of angle A is equal to H over B, and the sine of angle B is equal to H over A. Now, to figure out what the law of sine says, we're going to multiply each of these by the denominator to clear our fractions. So we're going to multiply everything here by B to clear those fractions. And I'm going to get that our H on this left side is equal to B times the sine of angle A. And I can do the same thing over here on the right. I'm going to multiply everything here by A to clear that fraction. So I'm going to multiply on the left and the right by A to get rid of that. So here on the right, I have that our H is equal to A times the sine of angle B. Now, because this altitude that I added in, I only added one side, which was this guy right here. That was our side H. This H and this H are the same. So I can set these two things equal to each other because that's the same H, which means that B times the sine of angle A is equal to A times the sine of angle B. This must be true in this triangle because this H and this H are the same side that I added in. Now, this is technically the law of sines. To make this look a little different, if you divide both sides here by AB, then we're just going to make this look a little different. The B's cancel on the left, and we're going to have the sine of angle A over side A is equal to the sine of angle B over side B. This is what the law of sines says. And similarly, we could actually draw an altitude down from any angle to its opposite side. So I could draw an altitude from angle A to side A, or I could draw an altitude from angle B to side B. And when we do that, we would find that the sine of angle A over side A is equal to the ratio of the sine of angle B divided by side B. And these are both equal to the ratio of the sine of angle C divided by side C. This is the law of sines. This one we are not going to provide for you on test 4 in the final exam. This is one that you have to memorize. And I also want to give you a heads up. Alex flips all of these upside down, so it puts the sides on top and the sine of your angles on the bottom. You can absolutely do that. These are ratios, so you can use them in any order. When I came up through math, I was programmed to have the sine of your angles on top and the side lengths on the bottom. So this is how I'm programmed. This is how I'm memorized. This is kind of the way that I operate. You're welcome to use this version or the version that Alex gives you. Pick your poison. They're both going to work exactly the same way. Okay, so what this law of sine says is that basically if you take the sine of any angle over the length of the side opposite it, the ratio is the same regardless of which angle you're looking at. And so we are basically going to use this to solve triangles because as long as we have one complete ratio, we can use that complete ratio to solve in the other pieces. That's how we're going to use the law of sines. And that also, to come back up here, that also helps us figure out when to use the law of sines. Anytime that we have a complete ratio, meaning we have the measure of an angle and the length of the side opposite that angle, we have a complete ratio. And so in all three of these law of sines cases, we are going to have a complete ratio. And if you don't have a complete ratio, that's when we're going to have to go to the law of cosines, and we'll see that on Wednesday. But for instance, here in the angle side angle case, notice that we don't have an angle and the side opposite it, but because I know both angles here, I can subtract from 180 degrees to figure out the measure of angle C here, and then I would have an angle and the side opposite. I would have a complete ratio. Here in number 3, this is also a law of sines case. Notice I'm given an angle here and the side opposite it. I have a complete ratio. That's why this is a law of sines case. And here in number 5, I'm given an angle and the side opposite it. This is a complete ratio. This is a law of sines situation. You'll notice here in our 2 law of cosines cases, we are not given a complete ratio. We don't have an angle and the side opposite it, and we don't have a way to immediately solve to find both an angle and a side opposite that angle. And so that's when we go to the law of cosines. So if you have trouble remembering when to use what, if you have a complete ratio or you can find one, that's a law of sines situation. All right, so let's try one of these. Here's an example. We'll do number 1. To solve this triangle, we are given that the measure of angle A is 64 degrees. The measure of angle C is 82 degrees. And we have that side C is 14 centimeters. Okay, so this is an angle side situation, and that means that we will use the law of sines. And again, to see that, we are given an angle and the side opposite it. We have a complete ratio. This is the law of sines situation. And so to solve this triangle with the law of sines, we're going to start with the complete ratio. We have angle C and the side opposite it. So we're definitely going to use this ratio because that's the completed one. And then we're going to set this equal to one of the other pieces of the law of sines. And the which one we use, whether we use this ratio or this ratio along with our angle C and side C ratio, depends on what we're given. The other information that we have here is angle A, which means we're going to use the ratio of the sine of angle A over side A, and this will help us then solve for something. So let's plug in what we have, solve for what we don't. So the sine of angle C is 82 degrees, divided by side C, which is 14 centimeters, is equal to the ratio of the sine of angle A, which is 64 degrees, over side A, which I don't know the length of. I'm going to leave that as A. So now we have uh, basically all of the information except for side A. We can solve for A. A lot of you were taught to cross multiply here. I don't really like cross multiplication because you then get confused about when you cross multiply and when you multiply across. So instead of cross multiplying, what I like to do is multiply both sides by your least common denominator. So if we were going to get a least common denominator here, it would be 14 times A. So I'm going to multiply both sides by that common denominator. And when I do that, I'm going to clear the fractions. And so when I do that, I'm going to get that A times the sine of 82 degrees is equal to 14 times the sine of 64 degrees. And I'm trying to solve for A here. That's my goal. And so to get to A, I'm going to divide both sides here by the sine of 82 degrees. So what that means is these are going to cancel, and A is equal to 14 times the sine of 64 degrees divided by the sine of 82 degrees. Now, this will have to go into our calculators and plug in. So we'll put that into our calculator. And when I do that, let's see. Sorry, I gotta dig my calculator out here. Hopefully gives you time to do the same. Okay, so make sure you are set to degrees because these are in degrees. If you're not set to degrees, the DRG button will do that for you. All right, so we're going to do 14 times the sine of 64 degrees divided by the sine of 82 degrees. And so when I do that, I get 12.7. Alex will tell you where to round on a test or a quiz. I will also tell you where to round. It looks like 1 decimal place is convenient here for us, so I'm just going to round to 1 decimal place. So A is equal to 12.7 centimeters. Okay. So I now have side A, but I am not done solving this triangle. I need to find all of the missing information. So now I have A equals 12.7 centimeters. I still need to find angle B and side B. So how do I start going about either one of those? Well, we can't find, normally we would find side B from the Pythagorean theorem, but in an oblique triangle, we don't have the Pythagorean theorem. We can't apply that. So we're going to have to find side B first, or angle B first, sorry. And we can find side B because we still have that all 3 angles add to 180 degrees. So to get angle B, I'm going to take 180 degrees and I'm going to subtract the 2 angles that we are given. And that's going to tell me how much is left over for my last one here. And I have 34 degrees for angle B. So now that I have angle B, this is 34 degrees. Now that I have angle B, we can figure out how to solve for side B. And again, we don't have the Pythagorean theorem, so we have to go back to our law of sines. We now have 2 complete ratios, so you can choose which one you want to use. I usually just start with the same one that we were given from the bat, like right off the bat, just to make sure that if I made any mistakes in calculations, I won't make it twice. But you can really use either one. And so if I start with the completed one that we were given, I'm now going to use that ratio along with the sine of angle B, which is 34 degrees, divided by side B, which I don't know, so I'm going to leave as the variable B. And now I just need to solve this out. Again, what you're going to do is you're going to take both sides here and multiply by your common denominator, which here is 14b. And when you do that, you get that b times the sine of 82 degrees is equal to 14 times the sine of 34 degrees. And to get to b, we're going to divide both sides by the sine of 82 degrees. And we can put that in our calculator. So b is going to be equal to 14 times the sine of 34 degrees divided by the sine of 82 degrees. And I get 7.9. And again, that's a side, so that's in centimeters. And now we have completed this triangle. We have solved for our missing information. All right. So number two, solving this one is very similar to the way that we just started. I'm just going to start this one off for you, and then I'm going to let you finish it on your own, because I really want to make sure that we get to the ambiguous case today. Um, so we'll just make sure that this is a law of signs situation and figure out exactly how to start, and then I'll leave you to it. So the angle A here is 40 degrees. Angle C here is 22.5 degrees. And side B is 14 inches. This is our given information. So because we are given two angles and the side between them, we are in an angle side angle. Just kidding, not angle, angle side. It's angle side angle situation, and this is law of signs. If you're less sure, come back up to our handy dandy table. Angle, side, angle is law of signs. Now, when you look at this directly, we aren't given a complete ratio. I don't have an angle and a side opposite it. So how is this a law of signs situation? Well, this is a law of signs situation because with the information that I have, I can compute. Um, I can find some missing information, and then I'll have a complete ratio. So notice I'm given two angles in this triangle. That means I know how big this one is because I can subtract from 180 degrees to find it. So the first thing that we're going to do is solve for that missing angle. So angle B is 180 degrees minus 40 degrees minus 22.5 degrees. And again, we will put that in our calculators. So 180 minus 40 minus 22.5 is 117.5 degrees. And so this is 117.5 degrees. And once I have that calculated, now I have a complete ratio. I have an angle and the side opposite it. Now I can go to the law of signs. So the complete ratio that I have is that the sine of angle B over side B is the sine of 117.5 degrees over side B, which is 14 inches. And I can use that to solve for each of my other missing pieces. So if I do, I'll do angle A first. So this is going to be the sine of angle A, which is 40 degrees divided by side A. And I can also use the law of signs, and I'll use my completed ratio here. And I'm also going to set that equal to the sine of angle C divided by side C. And now in each of these situations, you can solve for A and C. And then you will be complete. All right, I will let you do that solving. I just wanted to kind of help you start that one, but this is very similar to the solving above. All right, so law of signs, the ambiguous case here. So what makes the ambiguous case ambiguous? Well, that's because we can have 0, 1, or 2 solutions. So basically, for example, in side angle, let's say we are given side A, side B, and angle A. This would be a side angle situation, two sides and an angle not between them, because angle C would be between angle C would be between sides A and B. There we go. So basically what we're given is we know the length of side B And we know how big angle A is. And so we don't know how long this side C is. So I'm just going to put a dotted line in here. But we do know how long angle or side A is. So let's say A is this long. Well, if we are looking to solve this triangle, if B is this long, A is this long, and angle A here is this big. And so since angle A is this big, I know that my bottom side has to come along here somewhere. Now, if this is what our triangle looks like, in order to find a solution, I'm basically going to kind of use this side A length and kind of swing this around and change angle C here to figure out what angle C would make this into a triangle. But in this situation, my my side A is not long enough. It's never going to reach this dotted line down here. It's never going to allow us to complete a triangle. This is when we have no solution. There's no triangle that would make this work because A is too short. That's a situation where we have no solution. A is just too short. Another thing that can happen is what if A is longer than B? So if I know side B and I know how big angle A is, then I know where this bottom side is going to have to be. I just don't know how long it is. If side A is longer than side B, let's say it's this long, say that's how long angle A is, then again, we are going to basically use a circle here. Pretend that this is a circle and I'm moving this around. Then basically, if I swing angle A around to see where it hits this bottom dotted line, A is longer than B. It's only going to hit it over here. By the time I swing back around to the left over here, it's longer than B. It's outside my triangle over there, so I don't have anything else over there. So this is the case where we would have one solution. And basically that happens when A is longer than B. And then the last scenario we have, so let's say B is this length, and I know what angle A is. I just don't know how long side C is here. And let's say A is, try to make it, gotta be shorter than B. So I'm actually going to, sorry y'all, I'm gonna make this a little bit steeper here just to emphasize this point. So let's say side B is this long and angle A is this big here. Okay, so now let's say side A is this long. If side A is this long, then I don't know exactly how big anything else is. And again, I'm going to use this as kind of like a radius, and I'm going to swing this around in a circle and see where it hits everything. So let's say, there we go. As I do this, notice angle A hits over here, which creates one triangle right here. But I could also swing angle A or side A over here, and it also hits this bottom line over here. This creates two solutions. This happens when A is between the altitude length and the length of side B. The altitude is from here down to a perpendicular. That's the length of the altitude. So when the length of side A is between that altitude length and B, we create two solutions. Your two solutions here are basically this triangle right here, which is an obtuse triangle. That's solution one. And the other side is, here's B and angle A and side A. It could also be this, solution two, which is an acute solution. Okay, so let's go through one of these and figure out how to do this. So again, this is why this case is ambiguous. We can have no solution, one solution, or two solutions. So let's start with number 3 here. I am given that angle A here is 57 degrees and that side A here is 33 feet. And side B here is 14 feet. Okay. This is side angle. That's the law of sines. And again, this is the law of sines because I have a complete ratio. So what I'm going to do is I'm going to plug everything into my completed ratio. So the sine of angle A, which is 57 degrees, divided by side A, which is 33 feet, makes a complete ratio. And I'm going to start with the other piece of information which I have, which is side B is 14 feet. And so I'm going to have the sine of angle B up here. Now, hopefully you notice what's different about this scenario than what we've seen before. Again, we've plugged in our information and we only have one missing piece, right? We have the angle B is missing, but we have everything else and we'll be able to solve for it. But what's different about this one than what we've seen before is that every other time we've had an angle and the missing piece of information was a side length. When we've plugged into our ratio. But here, when we plug into our ratio, we have everything and we're given a side length and missing an angle. So we actually have to solve for that angle. That's what's going to create this multiple solution or no solution possibility bit. Again, we're going to start the same place that we always do, which is clear the fractions. I'm going to multiply both sides by our common denominator, which is 14 times 33. I don't know what that is. I'm not going to bother putting it in my calculator because I don't need to. So when I do this, I'm going to get 14 times the sine of 57 degrees is equal to 33 times the sine of angle B. Again, I'm solving for angle B here, so I'm going to divide both sides by that 33. And so the sine of angle B is this thing, 14 times the sine of 57 degrees over 33. Now, this is something that I can put in my calculator. So I'm going to say 14 times the sine of 57 degrees divided by 33. I'm going to put that in my calculator and I'm going to get 0.3558. So I've got that the sine of angle B is equal to 0.3558. 0.3558 is definitely not on the unit circle. But it is in the range of sine. It's between -1 and 1. I'm going to have solutions here. I need to find the solutions to this. We know how to do this. Sign is positive, which means I'm going to have solutions where sign is positive in quadrants 1 and 2. So I need a quadrant 1 solution and a quadrant 2 solution. To get my quadrant 1 solution, I am going to do the arc sign of my ratio. 5, 5, 8. Again, try not to round if you can. I'm going to do the arc sign of what I just got. And so when I do that, I get 20.84 degrees. That's my quadrant 1 solution. And now to find my quadrant 2 solution, I'm going to take that reference angle here from quadrant 1 and put it here in quadrant 2. This reference angle is going to match this one, and because it's in quadrant 1. So to get my quadrant 2 solution, I'm going to take 180 degrees and subtract that reference angle of 20.84 degrees. And so when I do 180 degrees minus that 20.84 degrees, I get 159.16 degrees. 159.16 degrees. Those are my two options for angle B. Again, when I take the arc sign of that ratio, these are options for angle B. I've got two solutions. I've got two options here for angle B. I've got to see them both through. So what if B was equal to 20.84 degrees? Well, in that case, then to find angle C, I would subtract from 180 degrees. So C is going to be 180 degrees minus that 20.84 degrees minus 57 degrees. So angle C is going to be 180 minus 20.84 minus 57. C is going to be 102.16 degrees. So now I have all my angles. The only side I'm missing is side C. So now I can use the sine of 57 degrees over 33 is equal to the sine of angle C, which is 102.16 degrees over side C, and I can solve that out. And you would get side C is equal to, I'm just going to do this real quick. You can double check this. We're pretty much out of time, so I just want to kind of get this down here. 38.47, and these are in feet. So that's the length of side C. And now we also have to check our other solution here, which is 159.16 degrees. So let's say angle B was 159.16 degrees. Then I'm going to subtract from 180 degrees with this angle and my given angle of 57 degrees. And when I do that, I get 180 minus 159.16 minus 57 is negative 36.16 degrees. There's not enough degrees in a triangle to support B being this big. That means this doesn't work. I don't have a solution for this one. This is the only solution here. This is a one solution situation. If you had enough degrees for both angle C's here, then you would just keep rocking with this process the same way you did the other one, and you would have a solution on each side here. So that's how we solve this first one with the ambiguous case. We'll come back to this on Wednesday and see a little bit more about the the ambiguous case, and we'll get to the law of cosines on Wednesday. So thanks for your patience while I'm not feeling well. I will see you on Wednesday. Have a lovely day.